Okay, guys, welcome to online learning for chemistry. This is going to be the format we're going to use over the next few weeks at least, where we're going to have some online videos to watch. It may be like this, it may be me at the whiteboard, but we'll have some online YouTube videos for you to watch. We will also meet together in Zoom at our slated class time, and through those means, plus your independent work like you always do, we will hopefully move forward in this course. So, ready or not, here we go. Let's jump into Chapter 8. Chapter 8 has more to do with stoichiometry and some other concepts like experimental error and percent yield, and let's go ahead and jump into that. So let's start by talking about a couple of important terms for this chapter, and that has to do with how we create experiments that produce good results. And there are two terms in particular that we care about where we are trying to get agreement in our experimental process. And one of those words, or one of those terms, is repeatability. And repeatability has to do with gaining agreement between independent results obtained with the same method on identical test material under the same conditions. That means we have potentially the same operators, or the same machines, or the same laboratories. In a nutshell, repeatability has to do with gaining the same results in multiple trials of the same experiment, but under the same conditions. Okay? We also have something called reproducibility. And reproducibility is agreement between independent results obtained with the same method on identical test material, but under different conditions. That means we might have different operators or different machines or different laboratories. In a nutshell, reproducibility has to do with gaining the same results in multiple trials of the same experiment, but under differing conditions. Okay? So obviously, if we have the ability to repeat, that means, right, doing things with the same environment, an experiment, or to reproduce, that means creating an experiment in a different condition. And if we get the same results, that tells us that we have created a good experiment. Our experimental process is good. And both repeatability and reproducibility help us in reducing experimental error. Let me write that out here. Okay? So, and that's what we want. We want experimental error to be reduced. Well, what is experimental error? Experimental error is the difference between a quantity's measured value and its true value. And obviously, anytime we're doing any kind of experiment, we want to have a measured value that is very close to its true value. We want to reduce experimental error. Now, another concept that ties in quite a bit with experimental error is that of percent yield. A percent yield has to do with comparing an actual value that we gain from a theoretical value. Now, what do I mean by that? Well, let's look at a chemical reaction real quick. I'm going to slide down here, okay? This is one of our problems, but we're going to look down here at the actual reaction that I have written, okay? This reaction says that we start with calcium carbonate, and that is going to be decomposed into calcium oxide and carbon dioxide, okay? Now, if I give you an amount that we're starting with, and then we use stoichiometry, right? Remember, stoichiometry allows us to compare substances in chemical reactions. So let's say we have a certain amount that we start with of calcium carbonate, okay? And then we know that through stoichiometry, we would be able to show how much we're going to create or how much we produce of either calcium oxide or carbon dioxide or both, right? If we know, if we are given, if we're given an amount of calcium carbonate, which is what they give us in one of our practice problems, 100 grams, then we should be able to calculate how much calcium oxide and how much carbon dioxide we produce, right? Now, when you use stoichiometry in that way, you are basically calculating what we call a theoretical yield. Okay, that is the amount you should produce. Theoretically, if you do your experiment, or if you do your decomposition correctly, if you run that chemical reaction correctly, this is a theoretical yield, okay? But you might actually, and oftentimes, you make a little bit less than that. You could also make a little bit more. There certainly is some experimental error if you end up with an actual yield that is greater than your theoretical yield. We are more likely to lose some of our quantity, that we don't capture it all, or it doesn't all react, and we have an actual yield that is less than our theoretical yield, okay? So our actual yield is what we actually produce. Our theoretical yield is what we should produce if we do our experiment correctly. Now, I want you to note, as what I've written on here, both of these amounts, actual yield and theoretical yield, should always be in grams. You're not comparing moles of substances in percent yield, you're actually comparing grams of things. And then you would take, to figure out your percent yield, you would take your actual yield, divide it by your theoretical yield, and then multiply it by 100%, okay? So, just to give you a sense of how these kinds of problems work, let's walk through one of the problems in our review questions, okay? So it says we have this particular, I think this is problem 4 maybe, we have this chemical reaction that I just gave you, whoops, and you're given, you start with 100 grams of calcium carbonate, and it says you make 45 grams of calcium oxide. What is your percent yield? I'm not going to walk you through it all, but I'm going to walk you through the process. So obviously, to figure out our percent yield, we have to know what values. Well, to figure out our percent yield, we would have to know actual yield. Let's try that again. It's hard to write sometimes. And we have to know theoretical yield. Now, what have we been given? He tells us we make 45 grams of calcium oxide. That is our actual yield. So then what we have to figure out is our theoretical yield. Well, how do we do that? Okay, let's walk through that. They've given us 100 grams that we started with of calcium carbonate, right? So calculate the problem is that we've got to calculate our theoretical yield using stoichiometry, and there's 3 steps to do that. We can take the grams of calcium carbonate we were given, which is 100, right? And we're going to turn that into grams of moles of calcium carbonate. Then we can take the moles of calcium carbonate here, and then turn that into moles of calcium oxide using stoichiometry. And then we can take the moles of calcium oxide and turn that into grams of calcium oxide using the molar mass of calcium oxide. And that will give us then our theoretical yield. So after steps A, B, and C, we will have theoretical yield. Then we can calculate our percent yield by taking the actual yield, which is that 45.0 grams, divided by our calculated theoretical yield. We would multiply that by 100% to get percent yield. So that is the process that we would be walking through in that particular problem. I just want you to see how those kinds of things work. We'll obviously walk through more of those in class next week, but that's the nuts and bolts of this part of the problem, of this part of the chapter. All right, happy problem solving, and I will look forward to seeing you on Tuesday.